one example, right? So let us take an example and let us try to understand even more clearly. Right? So here, so this is the problem I have taken. So is it visible? Right. So we just read once, just read it. Draw the radiation pattern of 4-element array. Draw the radiation pattern of 4-element array with lambda by 2 spacing between the elements. All the elements in the array are excited with equal amplitude and phase. Right? All the elements in the array are excited with equal amplitude and phase. Right? So like this. So 4-element array. Here we have 4-element array, 1, 2, 3, and 4, and all the elements are spaced lambda by 2 apart. Right? All the elements are spaced lambda by 2 apart. Right? And 4-element array. 4-element array in the sense capital N. Capital N is equal to 4 and K or small n, right? K or small n is 1, 2, 3, and so on, right? And D is equal to lambda by 2, right? D is equal to lambda. So this is the given data we have. So D is equal to lambda by 2. Small d means spacing between the elements, and capital N stands for number of elements in the array, and K or small n is the numbers, right? Natural numbers, 1, 2, 3, and so on, this one, right? And first of all, you need to identify whether it is broadside array or end-fire array, right? So it is broadside array. Why? Because equal amplitude and phase, right? Equal amplitude and phase. So therefore, this is absolutely broadside array, right? It is a broadside array, right? So for broadside array, and this is the expression for maximum directions of minor lobe, and this is the expression for minimum directions, that is null, right? Minimum directions in the sense null, and this is the expression for first null beam width, and one more thing is maximum directions of major lobe. So what are the maximum directions of major lobe? 90 degrees and 270 degrees. So these are the maximum directions of major lobe, right? And using the formulas, we need to determine maximum directions of minor lobe, and we need to determine null directions, and we need to determine first null beam width, and then we can draw the radiation pattern, right? So let us try to determine the maximum directions of minor lobes, right? Or simply minimum directions, right? Minimum directions, right? So what is the formula here? We have pi. Once again, I'm writing here pi max minor is equal to plus or minus cos inverse plus or minus lambda by 2 dn 2n plus 1. So this is the formula, I'm using small n, right? Instead of capital K, I'm using small n because in the derivation, I have used small n so that for avoiding confusion, I'm using small n here, right? So substituting the given values, what are the given values? D is equal to lambda by 2. Spacing between the elements is lambda by 2. And how many elements in the array? 4 elements. N is equal to 4. Right? So substituting these values initially, and what we will get? Plus or minus lambda by 2 into lambda by 2 into 4 2n plus 1. Right? Further simplifying this, plus or minus cos inverse plus or minus here lambda and lambda will get cancelled, right? So what we will be left with by 4, right? So lambda and 2 will get cancelled, and we have this one, right? So pi maximum directions of minor lobes we have, right? Now let n is equal to 1, right? Let n is equal to 1. As I have discussed, n is equal to 0 stands for what? N is equal to 0 stands for maximum directions of major lobe. So therefore, no need of substituting n is equal to 0, right? So therefore, it starts from n is equal to 1, right? So therefore, n is equal to 1. Substituting small n is equal to 1, which is for first minor lobe, right? Pi max 1 means first minor lobe maxima is equal to plus or minus cos inverse plus or minus 2n, right? 2n. So n is equal to 1, therefore 3 by 4, right? 3 by 4. And this is equal to plus or minus cos inverse 3 by 4 plus or minus cos inverse minus 3 by 4, right? So cos inverse 3 by 4, how much you'll get? How much you'll get? If you calculate this, I will give you the values directly here. 41.4 degrees. If you calculate, you will get these values, and 138.6 degrees, right? So these are the maximum directions of first null, right? Maximum sorry, no, not first null, maximum directions of first minor lobe, right? And now let n is equal to 2. So n is equal to 2 for what? Second minor lobe, right? Second minor lobe, right? So if we substitute this, what will get? Pi max 2 is equal to plus or minus cos inverse plus or minus 2 4 5 by 4 you will get, right? 5 by 4. So 5 by 4 means which is greater than 1, right? 5 by 4 which is greater than 1. So therefore undefined, right? So therefore no second side lobes exists, right? No second side lobes exists, right? It's only one side lobes, right? One side lobe, right? So these are the minimum directions which we have, right? And secondly, let us try to determine the null directions, right? Null directions or minima directions, right? Minimum directions or null directions, right? Minimum directions or null directions, right? And what is the formula we have? Minimum direction, this one, cos inverse plus or minus n lambda by dn, right? Here I am writing. So minimum directions plus or minus cos inverse plus or minus n lambda by dn, right? So this is the formula we have. Given data, small d is equal to lambda by 2 and capital N is equal to 4, right? So spacing between the elements is lambda by 2 and number of elements in the array are 4. So substituting and simplifying, what you will get, pi minima is equal to plus or minus cos inverse plus or minus small n lambda by lambda by 2 into 4, right? So therefore this is equal to plus or minus cos inverse plus or minus n by 2, right? Am I right? N by 2, right? So this you will get, right? And now let n is equal to 1, right? Let n is equal to 1. So what will get, pi minimum is equal to plus or minus cos inverse plus or minus 1 by 2, right? And this is equal to plus or minus cos inverse 1 by 2 and plus or minus cos inverse minus 1 by 2, right? So this is equal to plus or minus 60 degrees and plus or minus 120 degrees, right? And now let n is equal to 2. Let us see whether it is possible or not. Pi minima is equal to plus or minus cos inverse plus or minus 2 by 2 is 1, right? 2 by 2 is 1. So therefore it is possible, right? So this is equal to plus or minus cos inverse 1 and plus or minus cos inverse minus 1. So this is equal to what, 0 and plus or minus 180 degrees, right? So this you'll get. And let n is equal to 3, right? So pi minima is equal to plus or minus cos inverse plus or minus 3 by 2, 3 by 2 which is greater than 1, so therefore does not exist. N is equal to 3 is not possible, right? And now first null beam width. First null beam width is equal to 114.6 lambda by dn. Am I right? Let me check. 114.6 lambda by dn or nd. So this is equal to what? 114.6 lambda by 2 into 4, right? And this is equal to 114.6 by 2 and which is equal to 57.3 degrees, right? So first null beam width, right? First null beam width is 57.3 degrees. So these are the values, these are all the possible values which we will get from the given problem, and using the formulas, these are all the possible values we will get, right? And now the last step is draw the radiation pattern, right? Draw the radiation pattern, right? So let me summarize here, right? Let me summarize what are the values we got, right? So maximum directions of major lobe 90 degrees and 270 degrees, and maximum directions of minor lobes. What are the values we have obtained? 41.4 degrees and plus or minus, right? And plus or minus 138.6 degrees, right? And minimum directions. What are the minimum directions we have? Plus or minus 60 or plus or minus 120, 0 degrees, and plus or minus 180 degrees, right? So these are the values we have, and first null beam width is equal to 57.3, right? So these are all the values which we have obtained, right? Now let us try to draw the radiation pattern, right? So radiation pattern of what? 4-element array, spaced lambda by 2, equal amplitude, equal phase, right? 4-element array, space lambda by 2, equal amplitude, equal phase. So can you guess the radiation pattern? Yes, you can guess, because already this problem we have done, right? By using principle of multiplication of pattern, right? Let me show you that earlier, right? So we have discussed the principle of multiplication of pattern. This is 8-element array. Yes. So see here, and this is we have discussed earlier, radiation pattern of 4-element isotropic elements or 4-element array fed in phase, spaced half wavelength, right? Fed in space, in phase, spaced half wavelength. Same problem, right? Same problem we have done mathematically just now, right? So for this, what is the radiation pattern we have obtained? This one, right? So this is the radiation pattern which we have obtained, right? So this is the radiation pattern which we have obtained, right? Now let us see. We have used the mathematical approach, and let us see whether we will get the same radiation pattern or not. Yes, right? Um, right? So 0 degrees, 90 degrees, 180 degrees, 270 degrees, right? And maximum directions of major lobe, right? Maximum directions of major lobe along what? 90 degrees and 270 degrees, right? So therefore, maximum directions of major lobe along 90 degrees and 270 degrees. So this is 90 degrees and 270 degrees, right? Major lobe. So this is major lobe, right? 90 degrees and 270 degrees, right? So similarly, minor lobes, minor lobes. So what are the maximum directions of minor lobes? Maximum directions of minor lobes, 41.4 degrees, right? So somewhere here you'll get, right? So this is 41.4 degrees, and similarly minus 41.4 degrees, right? And 138.6, so somewhere here you'll get 138.6, 138.6, and minus 138.6 degrees. So these are the maximum directions of minor lobes, right? Maximum directions of minor lobes, right? So therefore, let me draw the minor lobes here. So this is one minor lobe, and this is another, and this is along 138.6, and again this is along minus 138.6 degrees, right? And now, is there any other minor directions, minor lobe directions? No, right? So there are no minor lobe directions, right? And now minimum directions, right? Let me indicate minimum directions, right? So here 60 degrees. So this is 60 degrees, and minus 60 degrees is this, minus 60 degrees, and 120 degrees. So this is 120 degrees, minus 120 degrees. This is minus 120 degrees, and 0 degrees, 180 degrees, right? 0 degrees. So this is 0 degrees and 180 degrees. So this is also a null, right? No radiation in this direction, and along 0, no radiation, right? And coming to, let us also indicate the first null beam width, right? So first null beam width. So from the graph, right? From the graph, what is first null beam width? This is first null beam width, right? So this is first null beam width from the graph, right? So because this is the first null in the sense no radiation, right? So this is the first null, right? So let me write here first null, right? So this is first null. So width between first nulls, width between first nulls is first null beam width. So what is this width from the graph? What is this width? This is 120 and this is 60. So 120 minus 60, how much? 120 minus 60 is 60. So therefore first null beam width, right? First null beam width is 60 degrees from the graph, right? From the graph, right? But using mathematical equation, right? Using mathematical equation, how much you got? 57.3 degrees, right? So using mathematical equation is the exact value, right? Is the accurate value, right? So therefore 57.3 degrees, right, is the first null beam width, right? First null beam width is this, right? And this is how we can draw the radiation pattern, right? So the same radiation pattern we have obtained, right? Principle of multiplication of pattern, there we have drawn the radiation pattern, and here mathematically we have drawn the radiation pattern. Again we got the same radiation pattern, right? Let me go back to that, right? So this one, so same radiation pattern we have obtained, the same radiation pattern we have obtained, right? So shape, I'm talking about the shape. So here in principle of multiplication of pattern, we can just draw the radiation pattern. We cannot accurately determine the directions, right? We cannot determine the directions. But whereas using mathematical equations, we can exactly determine in what directions the minor lobes are, right? So 41.4, 138.6 degrees, like that. We can accurately determine in what directions the minor lobes are, and in what direction the major lobes are, and in what directions the minor lobes are, and what is the width, right? That also we can determine. So once we know first null beam width, we can also determine half power beam width, right? Half power beam. So what is half power beam width? Let us say this is 1 by ETH, that is 0. Right? So this is the line 0.707. So this line intersects at this point and at this point, right? So therefore, if you draw two lines passing through this line and passing through this point, and this width, right? This width is half power beam width, right? So from the formula, from the approximate formula, we know that half power beam width is approximately equal to first null beam width by 2. So this is equal to 57.3 by 2, right? So this is a right? So this is half power beamwidth calculation, right? So this is how we can draw the radiation pattern of any complex array using mathematical equation, right? So I will give you a homework now. Same, right? Same procedure. You do it for 8 element array, right? So just now I have done for a 4 element array, right? Same for 8 element array, 8 element array, right? So do it for 8 element array. So this is the homework for you, right? 8 element I have done for 4 element array, and do it for 8 element array, right? So if you while doing the problem, if you got any doubt, you can watch the video, right? I will place the video in the YouTube channel, and you can go through it, right? So this is about broadside array, right? And now end fire array, right? Let us see, let us discuss about the end fire array, right? End fire array, right? So let me explain the conditions for end fire array, right? Let me explain the conditions for end fire array, right? So this is not a broadside array, so this is end fire, right? End fire array, right? So what are the conditions for broadside array? Alpha is equal to 0 and psi is equal to 0, right? So these are the conditions for broadside array, right? And now let us see the conditions for end fire array. So maximum radiation psi is equal to 0, right? Maximum radiation psi is equal to 0. It may be broadside or end fire array. Maximum radiation occurs when psi is equal to 0, because E is equal to E naught e power j psi, right? When psi is equal to 0, you will get maximum value. E is equal to E naught is the maximum, right? So this is the maximum, right? So therefore psi is equal to 0, right? Psi is equal to 0 is one condition. And we know that end fire array, what is the radiation pattern for end fire array? What is the radiation pattern? Radiation pattern is along the axis, right? So let this is the axis, right? Axis of the array, right? So what is the radiation pattern of end fire array? This one, right? Along the axis, right? So these are the side lobes, right? So along the axis, along the axis, along the axis in the sense what? Pi is equal to 0 degrees, right? Pi is equal to 0 degrees. So therefore, if you substitute psi is equal to 0, pi is equal to 0, right? If you substitute psi is equal to 0, pi is equal to 0 in the above equation, what you will get? Psi is equal to 0 is equal to beta d cos 0 plus alpha. Cos 0 is 1, right? Cos 0 is 1. So therefore, alpha is equal to minus beta d, right? Alpha is equal to minus beta d, right? So as I said earlier, the conditions for end fire array, psi is equal to 0 and alpha not equal to 0, right? And what is that alpha? Alpha is equal to minus beta d, and where beta is equal to 2 pi by lambda, right? Beta is 2 pi by lambda, and d, what is d? Spacing between the elements, right? Spacing between the elements, right? So for example, if spacing between the elements is lambda by 2, if spacing between the elements is lambda by 2, then what is alpha? Alpha is equal to minus 2 pi by lambda into lambda by 2, right? And this is equal to minus pi. Alpha is equal to minus pi, right? Minus 180 degrees. That means the phase, right? So n fair in the sense what? Equal amplitude out of phase, right? Equal amplitude out of phase. So therefore, out of phase by 180 degrees, right? Out of phase by 180 degrees. Here, when the spacing between the elements is lambda by 2, then alpha is equal to minus 180 degrees, right? So therefore, the conditions for n-fair array, right? Do remember this conditions for n-fair array: psi is equal to 0, alpha is equal to minus beta d. So these are the conditions for n-fair array, right? So very important for short answer question, right? And again, rest of the things are same. You can follow the same procedure when determining maximum direction. So here, what are the maximum directions of major lobe in broadside array? 90 degrees and 270 degrees. And now here, maximum directions of major lobe is equal to 0 and or 180 degrees, right? So these are the maximum directions of major lobe. And as we are saying that as per the definition, the n-fair array is unidirectional, so therefore we can take 180 as null, right? Only radiation along 0 degrees we can consider, only radiation along 0 degrees, and along 180 degrees is null we can consider. So therefore maximum directions of major lobe is 0 degrees and or 180 degrees, right? Now directions of pattern maxima, that means what? Maximum directions of minor lobes, right? Maximum directions of minor lobe, maximum in the sense array factor is equal to 1, right? That means what? Sine n psi by 2 is equal to 1, right? Sine n psi by 2 is equal to 1, right? So n psi by 2 is equal to what? Will get 1 in the sense plus or minus 2n plus 1 pi by 2, right? Therefore psi is equal to plus or minus 2n plus 1 pi by n, right? Now what is psi? Beta d cos pi plus alpha, that is psi, and this is equal to plus or minus 2n plus 1 pi by n, right? And here is the difference, right? For broadside array alpha is 0, and for n-fair array alpha is equal to minus beta d, right? So therefore alpha is equal to minus beta d. That is only the difference between broadside array and n-fair array, right? So therefore taking beta d common, cos pi minus 1, right? So because alpha is equal to minus beta d, so substituting alpha is equal to minus beta d and taking beta d common, we will get this one. So plus or minus 2n plus 1 pi by n, right? So simplifying this expression, cos pi minus 1 is equal to plus or minus 2n plus 1 pi by beta dn, right? And pi is equal to what will get? Pi is equal to plus or minus cos inverse plus or minus 2n plus 1 lambda by 2 dn, right? Plus 1, right? So since beta is equal to 2 pi by lambda, substituting beta is equal to 2 pi by lambda, and here this one to the right hand side, and we will get this, right? So this is the expression for determining maximum directions of minor lobe, right? So what is the difference between n-fair array and broadside array? Let me take you back here. So this, right? So almost the equation is same. right? The only thing is plus 1, right? So here you can see alpha. Here comes the difference, right? So in broadside array, alpha is equal to 0, and whereas in unfair array, here in this case, alpha is equal to what? Minus beta d, right? Earlier alpha is equal to 0, and now here alpha is equal to minus beta d. That is only the difference between broadside array and unfair array, right? And minimum directions, right? Again same, you do it, right? I will leave this as a exercise for you. You do it, right? So if you do it, you will get this equation, right? So this is the expression for determining minimum direction, that is null directions, right? And beam width, first null beam width, you will get this expression, right? You do it. I'm leaving it as a homework for you, right? So with this we have completed unfair array, and in the next class we will take an example, right, for unfair array, right? So with this I will close my session.